Hi guys, good afternoon. So in the last session, we have seen about the named mode EIGRP and we have seen about the HMX authentication, right? Okay. Now, today we'll start with the next topic, which is about EIGRP Stub. Now, what do you understand with the EIGRP Stub? So let's consider 4 routers. So first of all, why the stub is used? Okay. So EIGRP stub is used to limit the number of queries. Okay. In the network. It is used to limit the queries in the network. And where this is implemented is implemented in the edge routers. Okay. Now let's consider we have a scenario something like these are the 2 routers which are connected to each other. Okay. And these are basically what, let's say my HQ branches. So let's say this is HQ1. And this is my HQ2, right? Now, these are connected to different branches. Let's say these are my branches. And they're connected like this. Okay. And same way, HQ1 is connected here. And HQ2 is connected here. Okay. This is clear. Okay. So call it as a branch 1. This is branch 1. This is branch 2. And let's say we have one of the network here, something like okay, this kind of some network is there. Now what will happen? Generally, these HQs will have all the routes because they have to reach to all the branches. Correct? Now, if this loopback goes down, okay, consider this loopback goes down here. This guy goes down. So what your HQ1 will do? What happens in EIGRP if a route goes down? They will query others. They will ask others. So HQ1 is going to send a query to HQ2. At the same time, it is going to send a query to branch 1. Same time, it will send a query to branch 2. Correct? And then same thing your HQ2 will do. It will also query branch 1. This will also query branch 2. Now these guys, they will try to ask. That means a lot of query messages will be there. So we don't want these kind of query messages. Because we know that these edge routers, these are the branch routers, they don't have as much information as your headquarters. So what we want, that HQ1, okay, it can ask to HQ2. Maybe this guy is having some other way to reach here. But these guys will never have it because HQs will have all the routes. Understood? So if you want to limit these query messages, in that case, what we can do is we can configure stub. How do you configure stub? Okay. So we'll go to the branch routers and you will say router, EIGRP, ASN, and you will say EIGRP. This is only the configuration. So this is used to limit what? Query messages. Understood? So let's go and take a look practically. This thing noted, right? Okay. So you can see we have HQ1, HQ2, then we have branch 1 and branch 2. Start all the nodes. Yeah, only branches. Both branches in the edge routers. So let's write down the configuration. So this is R1. So Z0 by 0 interface, 12.1. Z0 by 1 interface, 11.1. Then we have Z0 by 2 interface, which is 31.1. Okay. Z0 by 2, this is 31 dot. Then we have a loopback 1.1.1.1 slash 32. Then let's configure EIGRP also. Router EIGRP. ASN, let's consider 1. Then I'll give the network 12.0. Then we have 11.0 and we have 31.0. Okay. Okay. Clear? Okay. Now, okay, this slash 24. This is clear. R1 configuration is done. Any doubt in the R1 configuration? So this is basically not R1, but HQ1. Okay. Then HQ2. Z0 by 0 is 12.2. Z0 by 1 is 21.2 network. Okay. So this is 21.2. Then Z0 by 2 is there, which is done. Loop back, we don't have EIGRP. So we have 12.0. Then we have 22.0. R2 configuration, that is HQ2 configuration is done. Then we have branch 1. Z0 by 0 is clown.clown. Z0 by 1 is 21.clown. There is no Z0 by 2 interface. Router EIGRP. Then we have 11 and 21 network. Done. And that is bench 2. 2. Z0 by 0 is 31.22. Then this is 22 dot 31. Done. Q1, then HQ2. Branch 1, branch 2. This is branch 2. This is very slow. The internet is also. On the server internet. Online people ಮಾಡಿದ್ದು.
Yes, sir.
Internet connection issues. You took branch 1. Then branch 2. So now everywhere we should have two neighborships, two adjacencies. You can see. On the branch 1, I have 2. On the branch 2 also, I have, right? On the HQ2, I should have 3. 1 with HQ1 and 2 with the other branches. Same way on HQ1 also, 3 should be there. All good? Okay. Now, if we check on branches, so if I say to show route EIGRP, so we can see we are having one route, right? For 1.1.1. Correct? Now, these guys, what they will do, they will start sending query if this guy goes down. So what I'll do, let's go to the privilege mode and I'll say debug EIGRP packets. Okay, and we have detail option, no. Okay, so this will debug all the EIGRP messages. So you can see sending hello. Right now we are interested in queries. So if you want, we can filter on the query also. But debug EIGRP packet query. So let's say query I want to debug, and another thing maybe SIA, but okay. We just want to look at the query packets. That's it. And same command I'll see in the branch 2 also. Done. So right now you can see there are no query messages. Now, interface loopback 1 shutdown. Take a look. They received query. So branch 1 received query from interface Z0/0. Take a look. Branch 1 received a query from interface Z0/0. Then sending query on the interface Z0/1. Correct. And also received the query from Z0/1. Sending query, receiving query, this is going on. Right? Same thing here. Received a query, then sending query. Understood? So we want to reduce this kind of traffic. This query traffic we want to reduce. So what we'll do, we'll go to the branches, router EIGRP1, okay, and I'll say what EIGRP stop. Done. As soon as I configure Stub, do you see what happens here? Neighbor has changed. Neighborship went down and came up again. Same thing I'll do here. Already in the EIGRP configuration, EIGRP stop. And here also you can see neighborship went down and came up. This is clear? Yes or no? Now, again, what I'll do, I will say no shut to this interface. So when no shut, that means these guys will not send the query this time. Query will be sent only if it is down. If your successor or feasible successor is down. So now we can see that there is no query. Okay, let me go and shut down it again. I said shut down. Now see. So did it receive any query here? No. No query received. This side also, no query received. So now HQs are not sending any query to them. HQs are not sending any query to them. This is clear. The HQ routers, they are not asking them. They will give an update that, okay, this guy is down. Okay, let's say if I debug update also, debug EIGRP packet, and let's say update. Okay. update query. First of all, let me stop all the debug. Now what I'll do here, one time I'll say shut down so that everybody will have that out. Okay. Now I'll say debug, do debug EIGRP packet. So we want query as well as update. Okay, and that's it. Enough. This is enough. Done. And same thing, let's say on the HQ1 also and HQ2 also. Done. Now here I'll go and also shut down. So you will see that HQ1 will send query where? See here. Sending query on Z0 by 0, sending update on Z0 by 1, sending update on Z0 by 2, and received an update on Z0 by 0. Now, where it sent the query? Only on Z0 by 0 only. Which interface? This interface to the HQ. Check on HQ2. Received a query on Z0 by 0 interface from HQ1, but it is not sending any query to anybody else. But it received a query from Z0 by 1 and 0 by 2. That means the branches were asking them. The branches are asking HQ, but HQs are not asking the branches because they now know that, okay, branches don't know anything. Whatever we will tell them, that is only the thing they will know, right? And at the branches, you can see they received update only. They received the update only, and then they are sending the query. So what we are trying to do with the help of EIGRP Stub, we are telling that, okay, the branches, they should not be queried for any successor or feasible successor because the branches do not have the entire topology information. They will only learn the routes which are informed by the HQs. So that means somebody who is going to have the information is the HQ only. Why to flood queries everywhere? Understood? So for this reason, EIGRP Stub is used. Clear? Now, in EIGRP Stub, we have different types of, you can say, levels. In EIGRP Stub, we have different type of stub levels. So if we check, when I configure stub, right, and if I get question mark, I have different types of stub. I have connected, leak map, receive only, redistributed, static, and some. These are the default. I mean, these are the stub levels. Now, by default, what kind of routes are advertised? By default, your connected and summary routes are advertised. By default, your connected and summary routes are advertised. Is it clear? So we can say do show run pipe section EIGRP, and you can see by default, I didn't give this entire command, right? But by default, only connected and summary routes are advertised. If you want to change it, you can say EIGRP stub and a specific level you can. Is that clear? So EIGRP stub has following levels. These are the levels. by default only connected and summary routes are as it is. Hmm. Only leak map routes, leak routes. Allow only dynamic prefixes based on leak map. It will not accept all the routes. Understood? What do you mean leak map down? So by default, somebody down. Hmm. Those routes will not be advertised. Okay. This is the default. If you want to change it, you can say EIGRP, stub, and you can define the level also here. Yeah. But this thing only if you want to change. If you want default, then you can keep on the EIGRP stub. Okay. Understood. Online people clear?
Yes, sir.
Okay. Noted. Next topic. What is the next topic? SIA, query and reply. The reliable messages. Although update, query, reply, these are also reliable messages. But these are two special messages in EIGRP. Okay. See here about the SIA query and reply. SIA query and SIA reply. These two packets are used during a prolonged diffusing computation to verify whether a neighbor that has not yet sent a reply to a query is truly reachable and is still engaged in corresponding diffusing computation. What do you understand? Understood anything? No. If see here, this line will explain everything. If you read this line will explain what is SIA query and reply. This is what that technical language means. Let's say a router has lost a successor or feasible successor. So definitely it is going to send a query. But how do I know whether my neighbor is working on my query or not? How do I know my neighbor is working on my query or not? Because I will query my neighbor will query somebody else. And this process will keep on going if multiple routers are there. That means when the last router will respond, then again the reply will come. But how do I know? What if it takes a lot of time? If it takes a lot of time, what will happen? My neighborship will break. My neighborship will break because once my feasible successor is down, my route state will change to active. My route state will change to active, and the active timer is 180 seconds. Active timer is 180 seconds. That means if I receive a reply within 180 seconds, I will update it to passive again, right? That means the route is reachable. But what if the reply is coming after 180 seconds? There is no meaning of that reply. So because of that, I will break the neighborship because my neighbor did not reply to me on time. That means I think my neighbor is not available, right? Not a good neighbor. So we want that, okay, this breaking of neighborship should not happen. These neighbor relationships, they should not get broken. Okay. And to avoid the breaking of neighbor relationship, what do we have? We have the SIA query and SIA reply. Understood? Okay. So if the neighbor is reachable and still engaged in diffusing computation for the destination specified in the SIA query, it will immediately respond with the SIA reply packet. So simply to understand, your SIA query is a must reply packet. Normally, I'm sending a query. Okay. And the reply will come when he will get the information. But if it is taking him too long to send the reply, I will send SIA query. And he has to reply to the SIA query. Doesn't matter the response has came or not. When I will get the SIA query, sorry, SIA reply, then I will know that, okay, he is still working on my query. So instead of breaking the neighborship, I will wait again. Why? Because my active timer, 180 seconds, that timer will reset. As soon as I get the SIA reply, my timer will reset. Again, I'm waiting for 180 seconds. Then again, after 90 seconds, I'm going to send a query because SIA query message will be sent every 90 seconds. Every 90 seconds, I'll send a SIA query. That neighbor has to reply that, okay, wait for it. I'm still working on your query. So once I receive a reply, again, that timer will reset to 0. Again, it will go for 90. Again, it will send. Again, it will go for 90. Again, it will send. Like this, it will prevent breaking of neighborship, breaking of adjacencies. This is why your SIA query and SIA reply is there. So here the language is too technical. Let me see the other book. Fundamental EIGRP. Hello and full timer. SIA means stuck in active. Here the message information is not there in this book. I think we okay, let it be. So we'll take this language. Okay, understand. SIA means stuck in active. Query and reply packets are used to reduce the breaking of neighbor relationship. When a successor and visible successor goes down, the router will send a query message to its neighbor to ask for a route, or you can say to ask if it has a route to reach a network. Okay. That is what I'm telling you. So when a successor or visible successor goes down, okay, here, for example, in bracket of router, I'll say R1 just in bracket so that it becomes easy to understand. And neighbor, let's say I'll call it R2. Okay. It's neighbor R2 to ask if it has a route to reach the network. Okay. So the router who R1 will put the route in active state and the active timer will start. The active timer will start. The default value of the active timer is how much? 180 seconds. Okay. If the router we are talking about R1 receives a reply from the neighbor. Who is the neighbor? R2. Before the active timer expiry, it will not break the inhibition. But if the router, same thing, the router R1 receives a reply from the neighbor or we can say does not receive a reply. Does not receive a reply from the neighbor before, or we can say in 180 seconds. It will, what it will do? Break the neighbors. Okay, and this is a scenario. Understood? Okay. Now this is where your SIA query and reply comes in. Okay. The SIA query packet is used to ask a particular neighbor to confirm that it is still working on the original query. Okay. This is used to ask the neighbor that, okay, it is still working on the original query. So you can say the router, who is the router? R1 will send SIA query packets. Okay, and how frequently it will send? Every 90 seconds. Every 90 seconds. The SIA query is a must reply packet. Okay. If the neighbor receives, okay, if the neighbor receives an SIA query from the router is R1 and the neighbor is R2. Okay, this is a hypothetical situation. So if the neighbor receives an SIA query from the router R1, it will reply with SIA reply message to inform the router R1 that it is still working on the query. Okay, and the router R1 is sending the SIA query packet every 90 seconds, right? Why? To check whether R2 is working on the query or not. To check whether the neighbor is working on the query or not. This is clear. So you can say that 90 seconds. If you want to add, if you understand, that's okay. Otherwise, I can type also, that is fine. Okay. To check if the neighbor is working on the query. This is clear. Now, what happens if R2 replies to R1 with a query. So when the router, that is R1, receives a SIA reply packet from the neighbor is R2, it will reset the active time. This will prevent the breaking of neighborship. Understood the entire scenario? Any doubts? We have routers R1 and R2. On R1, a particular successor or feasible successor goes down. So R1 will query R2. Now, R1 can by default wait for 180 seconds only. If there is a reply within 180 seconds, it is fine. If there is no reply, then after 180 seconds, R1 and R2 will break the neighborship, considering that my neighbor is not responding, right? After that, to avoid that breaking of neighborship, what we can do is we can, not we, but the EIGRP is going to use the SIA query masses. Okay, and one more thing, mention it at the top only. This was not available initially. Okay, the SIA query and SIA reply messages are introduced after iOS version 15.1. Okay. Initially, these messages were not there, but after the iOS version 15.1, they were introduced. Initially, these kind of problems we were facing. Clear? Note it. Online people clear?
Yes, sir.
So let's go to the lab and see the lab. Now, this is the scenario we are going to consider. Okay. This is the scenario. Simple three routers are there. One more thing is there about SIA query and reply, that how many SIA query messages it will send. That you can Google it, okay? Right now, I do not recall the exact time that how many SIA query packets will be sent. Take it as a task. Or you can check now if you want. Passive interface, everybody knows. I think in the RIP we have discussed same concept here also. If we will use a passive, I think in the neighborship criteria we have discussed, right? Authentication and everything we have discussed. That part is not there. Okay. Yeah. So see here, this is the lab. Let's start all the notes. First, let me wipe all the notes. Now, practically showing this that yes, it is breaking the neighborship and all. That will not be possible because iOS version 15.x we are using. Okay. So here SIA query and SIA reply is there. So but just with the packet capture, I will show you the SIA query message and SIA reply message. So 3 routers we need. This is R1. 12.1. Gigabit interfaces are not there. Loopback is there. Done. R2. This is 12.2. 0/1. 23.2. Loopback is not there. Done. R3. This will be 23.3. 0/1. Now, okay. 23. Okay. All 3 routers configuration done. Take access of the routers. R1. R2. R3. R1 configuration. R2, R3. Done. So let's wait for the neighborship. Neighborship came up. Here also two adjacencies came up. Okay, everything looks good. To show. But you know what will happen? We will not be able to see the SIA query and reply also. Why? Because what will happen? R1 will send a query to R2. R2 will send a query to R3. R3 will immediately send a query here. R3 will immediately send a query to the, reply to the R2 that I don't know where it is. And same way then R2 will also send it. Okay. So for this reason, what we can do is, okay, let's see if I can create the scenario. On R2, what I'll do is, see, on R2, this side, I'll increase the hold time. What is the default EIGRP hold time? 15 seconds for the faster networks. 5 and 15, right? Yes or no? Yes. Sure. Right? Correct. What is the EIGRP hold time? Correct. 5 and 15, 60 and 180. Correct. So right now we are using gigabit link, so it is 5 and 15. And how do I verify? How do I verify the whole time? Okay, let's check. Show IP, EIGRP, interface, and the interface is Z0 by 1. In detail or summary. Obviously. So it's unrecognized comment. So what was the comment? Show IP interface. Do we have EIGRP here? One. Interface is 0/1. Detail is not okay. Interface detail it is. So we can see for Z0 by 1 interface here, 5 and 15. So this from 15, I'll increase it to, let's say, our time is 180 seconds, right? Okay, we'll increase it. Okay, tell me, where should I increase the whole time? On R2 or R3? Right now I check on R2. You can see this is the hello and hold time, right? And if I check here, it will show IP, EIGRP interface. Here also 5 and 50. So should I increase the whole time on R2 or like when, let's say, I change on R2? So that means for R2 it will get changed. Yes or no? And if I change on R3, if I give the command on R3, what will happen? It will change on R3, right? Let's check. Interface gig 0/0. I'm doing it on R3. Okay, verify this. IP hold time EIGRP1, and let's say I'll make it 360 seconds. Okay, or let's say 3600 seconds. Done. Let's see. What happened? You can see. And I changed it on which interface? I gave the command. So that means command doesn't work, or you cannot change. Hmm? Huh? Okay, you mean to say 0/1. Okay, yes, you're right. No problem. Now it is 3600 seconds. Last time interface was in fact. Let's check here. Did it change anything? No. So what I'll do, what I'm trying to say is I'll go and change the hold time. So hold time means this is how long it is going to wait. And after that, on R3, we will shut down the interface. R3 will not send hello messages. So that means when this guy will send a query, R2 will not get a reply. Got it? So if R2 will not get a reply, R2 will not send any reply to R1. Okay, so let's change it. Configure terminal interface gig 0/1 of R2 IP hold time EIGRP1, and let's say I'll set it to 3600 seconds. Now we should be able to see it. Okay. Now let's start the packet capture on Z0/0 interface. So right now you will see hello messages and everything being forwarded. Correct? You can see. Okay. So let's focus on EIGRP only. These are the EIGRP messages. Here you can see 22 continuously messages are there. Only hello messages. Now what? I'll go and shut down R3. Okay, so interface gig 0/1 and shut down. This guy will not send what? Right? Done. On R2, you see neighborship did not break yet. Now let's go here and shut down the loopback interface also. Interface loopback 1 and shut down. Query message. We can see the query message here. Now, after 90 seconds, if it doesn't get a reply, if your R1 doesn't get a reply, it is going to send what? SIA query. Okay, and right now we can see that, okay, this guy will put the route in the active state. To show IP EIGRP topology. Do you see this route? Active 1.1.1.0/24. There is only one successor, and right now what is the FT? Infinity. Okay. Now wait for it. How long it has been active? 31 seconds. Okay. Has been active for 31 seconds. 58 seconds. And also keep focusing here. Okay, this side on the package messages. Now let me do one thing. I'll just set it like this. Okay, we will see SIA query in some time. 1 minute 28 seconds. Do you see here? SIA query message. This is the SIA query message, and R2 replied that yes, I'm still working on it. Again, after 90 seconds. After 90 seconds, this guy will send again that, okay, are you still working on my query? So R2 will not get any response from R1. So again, what will happen? He will send reply, I'm still waiting for my neighbor. Okay. But what is going to happen? Again, as of now, see here, 2 minutes, 18 seconds. After 90 seconds again, it will send SIA query and reply. Wait for it. So you can see one time retry. Two minutes 49. Now this guy sent a reply and the route has been removed. Why? Because this guy also did not get any response. Active timer was there. That guy also did not get any response. So neighborship down. You can see R2 has broken the neighborship. See what it says? Neighbor 23.3 is down. What is the reason? Stuck inactive. Because this guy also has an active timer. Understood? So this is how it works. SIA query reply clear? Online people? Okay.
Yes, sir.
Then let's go with one last concept of EIGRP. So earlier, remember when we were using variance and all those things. So what we were trying to do, we were trying to increase the matrix, decrease the matrix, right? These kind of things we were trying to do. There is one more way to do it. Okay. So this is known as EIGRP offset list. For a particular route, we can increase the matrix or decrease the matrix. Clear? So you'll say offset list is a way to increase or decrease the matrix of a route. Okay. Clear? And you can again apply it in the inbound or outbound direction. So it can be applied in the inbound or outbound direction. Okay. Now, how to apply it? So again, we will create an access list and use that access list we will attach in the offset list. That's it. So same like distribute list command is there, right? That is there. Now let's see here. If we see an example here, so let's say R2. Let's take the same lab. Only R1 and R2 is required, so nothing extra. So let's say the loopback interface, I'm again bringing it up so that R2 can have the route for it. Okay. On R2, interface gig 0/1 and I'll shut down so that we don't go on the R2 side, R3 side. Okay. So as of now, you can see here on R2, if I say you would show IP route EIGRP, we have only one route, which is for 1.1. And what is the metric right now? This is the metric. Note down this metric. Okay, this is the route we have as of now. This is the metric before changing anything. Okay. So I can say something like this is without offset list. Now, how do you apply the offset list? So first of all, you create an access list to select the network. We access list. So you'll say access -list. EIGRP. That's why I said EIGRP offset list. New ones. Here you will give the ACL number. Then you will say permit or deny. Here we will say permit only. Okay. Then after, here you will give the network ID. Then you will give the wildcard mask. Once access list is created, then attach access list to the offset list. So you'll say router EIGRP ASM. Okay. Then you're going to say offset list, give the ACL number. Okay. After the ACL number, you have to tell the direction, either inbound or outbound, how you want to apply. Then after, you will say what is the offset value. So this is the metric that you want to add on. Okay. And then after, we'll do the inputs. Clear? Now we will apply this and then we are going to see what are the changes in the metric. How many sessions for EIGRP? 6 or 7? 7. I try to keep it less. Still. Yesterday's session was 1 hour only. Noted. Done. Okay, no done. Okay. So now take a look. On R2 right now, when I check, this is the metric of this route. Let's go here. And to change it, I will use it on the outbound interface, outbound direction on the interface, gig 0/0. So let's go here and I'll say access icon list. Let's say 1 permit 1.1.1.0 000 255. Done. Router EIGRP ASN. Then we will say offset list. ACL number is 1. Okay. After that, what we have to give? Inbound or outbound. So right now I want to configure outbound. Then what do I have to give? I have to give the offset value. Okay. So offset value I have to give. So let's say how much offset values we should give. Let's say 20,000. Okay. Then through which interface? Gig 0/0. Done. Let's see if any changes on R2. Wait for it. You can see the changes. We increased 20,000. So this was like 1,30,000. Now it is 1,50,000. Is it clear? So we added 20,000 as an offset in the metric. So this is also a way to change the metric. Understood? So that means rather than changing delay or bandwidth, we can attach an offset. Understood? Okay. So this is the value after offset. Hmm? What update? Offset. So whatever the metric you want to change, incoming or outgoing, you just have to work on metric. That's it. If you want to change AD, you will change for the next router. If you want to change FP, you change for cell. Okay. So with 20,000 as offset. Once we set 20,000 as offset, then after this is what we have. Correct. And with this, your EIGRP is done. Now, next session, that is tomorrow, we will start with the EIGRP. OSP. Actually, for so long, I have been talking EIGRP only, so that's why. EIGRP is done. OSPF we will start. Still, we have OSPF and BGP. I guess 24, we have a switching batch. Have you guys done switching? Nobody has done, right? Then no problem. We can extend it 1 week. Okay. All right, then. This is it for the day. Online people, any doubt?
No, sir.
Sir, on 24th, I have joined switching. So are you planning to extend, change
No,
the
not
batch?
really planning. We can do it like 1 hour switching, 1 hour routing. Okay.
Okay, fine.
Parallelly switching will also go on. Otherwise, students who will be joining for switching, they can get offended.
Okay, fine.
Right. Okay, then that's it for the day. Any other doubts? No. Will you share the PDF file? Which PDF file? I think I have shared all the files. Any file is missing?
No, sir, actually, that which you have opened, Cisco PDF file, so that
Cisco?
one I asked.
I guess I
Sir.
not shared. Okay, I'll share it now.
Yeah.
I'll share.
Thank you, sir.
Okay, guys. All right, then. See you guys.